Okay, so there was just a video posted about how to add fractions with like and unlike denominators, and I wanted to also do one on subtracting because they work very similarly. If you recall from the adding fractions video, you only add the numerators, the denominator stays the same. With subtraction, it's a very similar story. You only subtract the numerator and the denominator stays the same. Just like in the addition video, this is because the size of the pieces does not change. That denominator tells you what size of the pieces are. Okay, so this is saying if I have 6/8 of a pizza, let's say, and you take 3 of the 8 pieces, I would only have 3 left over for myself. Okay, so if I see a problem like this, 7/3 minus 2/3, I would subtract only the numerators. 7 minus 2 is 5. Denominator stays the same. You'll notice this is one of those improper fractions. If you want to convert that to a mixed number, make sure you check out the video on converting an improper fraction to a mixed number, okay? Over here we have another one, except this time you're going to notice that the denominators are different, okay? This one's in tenths, this one's in fifths. Until we get the same denominator, we cannot subtract these. So I'm going to use what I know about equivalent fractions to change that denominator so that we can subtract it. Okay, I'm going to change the fifths into tenths by creating an equivalent fraction. Video on that if you need help. Okay, I'm going to do 5 times 2 because I know 5 times 2 makes 10. Remember, when you create an equivalent fraction, you have to multiply or divide. If I multiply by 2 on the bottom, then I have to do it to the top. And now I'm going to change this fraction into its equivalent fraction. So 1 times 2 is 2, and 5 times 2 is 10. You'll now notice we have the same denominator, and I can subtract just like we did over here. 7 tenths minus 2 tenths. 7 minus 2 is 5, and then the 10 stays the same, 5 tenths. Some of you might recognize this as an equivalent fraction to 1/2. All right, down here, let's look at ones where no matter what I do, there's no way to turn a 2 into a 7 using multiplication or division. When that's the case, just like when you added fractions, you're going to take the fraction on the left and multiply it times the denominator of the fraction on the right. And then for your fraction on the right, you'll multiply by the denominator from the fraction on the left. Multiply by the opposite denominators. Okay, so let's see what that gives us. 6 times 2 is 12. 7 times 2 is 14. Minus 1 times 7 is 7. 2 times 7 is 14. I now have 12 fourteenths minus 7 fourteenths. 12 minus 7 is 5. Denominator stays the same. Let's work one more of those. Once I get it set up, why don't you pause the video and try it on your own, and then you can resume it once you're ready to check your work. Let's try 8/12 minus, let's do 3/5. Okay, go ahead and pause here. All right, if you're ready to go over the answer, here's what you should have. 8/12 I'm going to multiply times 5, that opposite denominator, as I work to create a common denominator, denominators that are the same as one another. And then my 3/5 I'm going to multiply by 12, the opposite denominator. Remember, whatever you do to the top, you have to do to the bottom. And I'm going to see what my equivalent fractions are that I've just created. 8 times 5 is 40. 12 times 5 is 60. Minus 3 times 12 is 36. And 5 times 12 is 60. Equals. I have 60 for both of my denominators, so I'm good to go ahead and subtract. 40 minus 36 is 4. Denominator stays the same. All right, go ahead and give a few of those a try as well, and maybe touch up on your adding fractions as you work through these.